飛行機友達のキッシーさんと一緒です。バッションエアクラフト、これ何ですか？
ここは小さい飛行機、ライトスポーツエアクラフトと呼ばれる飛行機を作っている会社で、ウッディンビルにある会社ですね。
はい、うちから10分です
こんなところにあるとは思わなかった。
隣はダイノのエアアビオニクスの工場があってね、今日ちょっと見学させてもらいます。よ
ろしくお願いします。
よろしくお願いします。
So this is our production. This is where we make the airplane, and then with the wings and the fuselage and everything else. I mean that's part of it over there. And then once the airplanes are completed, then we put them in a truck, send them out through that door, and then we take them up to Everett, up to Paynefield and Everett, and then that's where we will put the wings and the fuselage together. So this is what we call kind of laying the keel. This is the first stage of the Ranger. So from here to actual flight testing and production and FAA inspection takes usually about 8 to 12 weeks.
8 to 12 weeks.
Right, and because it depends a lot on kind of logistics of moving things through and if there's any issues or anything like that, and especially when we get onto the other side, which is up at the hangar where we do the final production of it. It could be that the airplanes in front of them, which we've had especially all of last year when we had really bad weather with smoke and then the weather itself and that kind of thing, we couldn't do the flight testing. So that kind of backs up the system because the airplane, the hangar up there can only hold X amount of airplanes. If it goes all the way through, it takes about 8 to 12 weeks. So everything starts over here. Well, I guess technically everything starts there. That's our parts center.
Yeah, it's parts center.
But the aluminum arrives to us, the exterior aluminum anyway, arrives to us already coated. So it's already painted when it gets to us, so we don't have to worry about that. About 90% of the airplane we build right here. So yeah, exactly. I mean, obviously we get the nuts and bolts and that kind of thing from outside. About the only thing that we do not make is the main gear, the landing gear.
Okay.
That's a fiberglass epoxy kind of composite material.
So, but when your airplane goes out from this factory, everything, including the main gear, is put on.
It is, correct. And I'll show you. So we're going to kind of go that way and come around the other side so that you'll actually see what for this side of production, what the end product looks like before it goes out the door and heads up to the hangar. Depending on the part that we're making, which machine we use to bend it to what we need it to be. It could be, the leading edge of the wing. It can be the side of the fuselage. So it really depends on what part that we're looking for as to which one of these machines it goes to and then what happens from there. And then that actually was our very first production.
Is this a prototype?
That's the prototype, yeah. This one even shows the header tank, which is this right here, is now up front. So a lot of this has changed from what it was before. So the header tank is, and I'll show you on the other airplanes. So this is actually now right in front of in the panel. So the header tank really serves two purposes. This is one reason why it was moved up there. Is it serves as a keeping positive fuel flow into the engine at all times because we don't have a fuel pump on the airplane. It's all gravity driven. Exactly. So, and then it also adds an additional 30 minutes of an emergency reserve. Though before you get to the header tank, there's all kinds of warnings that go off on the screen and in your ears as to, low fuel and that kind of thing before you get to the header tank. And the header tank, as I said, gives you an extra 30 minutes just in case. We kind of built it as an additional layer of safety so that if you're flying VFR and you get caught on top of clouds or something like that, and you're trying to get back, you know that no matter what happens, you still have extra fuel to try and get you to where you need to be. Yeah, so this was the first one. This was the one we tortured through the whole process.
Well, it's experimental.
It is experimental, and that. So we experimented on it. Exactly.
That's a,
and then any cutting of either the aluminum or all the bits and pieces for the airplane are all done in these machines over here. So like I said, the way it kind of works out is, everything comes in that door, kind of works its way through here, and then goes out that door. One of the design philosophies of the Ranger is that it's designed that if the Ranger has to land in the middle of the United States somewhere for some kind of maintenance, whatever, anything can be accessed and repaired by a mechanic in a pickup truck. It doesn't have to go into a shop. So let's say that there is a fuel issue. It's designed so that the fuel tank can come out, be fixed, and put back in.
Wow. Quick repair.
Exactly. So even on this, so any part of the airplane that has a motor or something that needs to be fixed has an access panel. So it's not that to fix something you have to take a piece of the airplane off. You're just going through the access panel. So for this section, this is where the trim motor, so for the elevator, the trim motor sits right in here. So to fix it, it'd be take the panel off, do what you need to do, put the panel on, done.
so was it the design concept for you guys that the pilots just flying everywhere in the countryside and then try to make it easier to be maintained or fixed by anybody?
Correct.
Any
Any A&P. That's why we went with the Continental 0200 engine versus the Rotax.
I see.
The Rotax would have saved us 30 pounds. But it's there's not a lot of pilot or mechanics in the U.S. that can work on a Rotax engine.
EU made it engine.
Exactly. Whereas in the U.S., when most A&P mechanics show up at mechanic school the first day, it's the Continental 0200 that's sitting on the bench.
I see.
So it's, every mechanic in the U.S. knows the Continental 0200, and it's been around for 70 years.
Right.
If the airplane has to land for whatever reason in, Podunk, Iowa, in the middle of the United States, an A&P in any shop can pull up, let's say it lands at an airport that there is no A&P shop, but there's an airport 10 miles away that has one. He can drive over 10 miles, fix the airplane, because there's nothing on here that they wouldn't have seen before.
I see.
The only thing that the owners would have to come back to us for is the landing gear. Everything else, they can get it online, or they could, the mechanics can get it from wherever they get their supply and get the same screws that we have in our airplane. Now, those are not aviation approved, but, if you're not really, paying close attention to that, then you can go to Home Depot, get the same screw, put it in, and fly home.
Cool. That's the spirit.
Yes, exactly. The header tank now. But everything goes into what we call the red box. So the red box is really the brains of the operation. So everything goes in there. So even, we have a pitot-static system which gives you your airspeed and the altitude and that kind of thing. Well, it really is not what you would find on, say, a Cessna or a Piper or that kind of thing with the vacuums and that kind of thing. It really is, the information hits the pitot tube and is interpreted by the box and put up on the screen to show you what your airspeed is and what your altitude is and that kind of thing.
So the red box has the processor unit in?
Correct.
I see.
Correct.
So I did training in Cessna 152.
Okay.
It has a very classic panel.
Yes.
So in training, I have to calculate the two airspeeds by hand, but this system
it shows it on the screen for you.
Okay.
So you get your exactly. So it does on the screen. It'll show you your indicated airspeed, and then right below that will be your true airspeed, and then below that is your ground speed, which it takes off of the GPS.
Excellent.
So everything's right there.
Integrated.
It's completely integrated. And then on the altitude side, you have the indicated altitude, then you have the density altitude. So that's also indicated. And then it also gives you the GPS altitude. So there's, a lot of times for people that are transitioning over to this airplane, a lot of this time it can be information overload. Because a lot of times they're using too much information. They used to have to calculate it on their own. Now it's just there in front of them, kind of thing. This is This is the panel for the IFR airplane. Ooh. So it has the 2 Dynon screens here, the audio panel here. There's a Garmin box that's going in here, which is what is making the IFR, because the Dynon HDX is VFR only. But we have to have an IFR navigator in there, which is something that we can use to shoot ILS approaches. Because essentially right now, even with the HDX system, you can shoot GPS approaches with it. But to do ILS, localizer, VOR, DME, well not DME, but VOR and yeah, those kind of approaches, you need to have this box to do that. Correct. Exactly. And it has to be in panel for it to be legal. The antennas are going to be on the belly, and then up on the wing to receive the ILS and the VOR information, which is then going to be interpreted by the box and displayed on exactly. So you'll still see the needles on the main screen, but it's being fed exactly because the HDX system doesn't have that built into it. It just can do the GPS thing. So anything else, so basically if you think of it, anything that has any kind of radio transmission coming into the airplane that needs to be interpreted, that goes through the Garmin. Any other, so like GPS or anything, that comes in through the HDX.
What was the motivation of the Vashon to even help IFL pilots?
Because one of the main markets that the airplane was designed for was flight training.
I see.
That was so it's built for flight training and to fly in the backcountry. That's why we have the big tires and that kind of thing. And the flight schools were very, very interested in the airplane because it's a lot less expensive to operate. It's newer, so a lot of pilots don't necessarily want to go into the 152s to learn off the round dials when they can learn off of a glass screen kind of thing. Especially if they're looking to go onto the airlines. If they're looking to go onto the airlines, they want this exactly. So flight schools were very, very interested in that. But the one feedback we kept getting is we didn't have an IFR airplane. So what would happen from the flight school perspective is they'd have a primary student who would learn in the Ranger, but then they'd have to go over to a 152 or 172 or a Piper or something like that to do their instrument, to then come back over to do the commercial and ATC and that kind of thing, which meant from a flight school perspective, they had to have 2 fleets of airplanes. So that's, different parts, different, maintenance, all that kind of stuff, as opposed to having just one airplane that somebody can start with 0 hours and go all the way to 250 hours in, kind of thing. So from a business point of view, the flight schools just couldn't justify it. As a flight instructor, instructing in this airplane, I've instructed in Cessnas, I've instructed in Pipers and that kind of thing, and not just because I work for the company, but instructing in this airplane is an instructor's dream. First and foremost, because of the width. I'm a big guy. Exactly. I'm a big guy, so for most of my students, I either had to sit back a little bit, and if I need to take the controls, I had to come forward to take the controls, or the student would be up in my armpit. In this airplane, I have never rubbed shoulders with anybody in this airplane. Never.
It's wider than 152.
It's actually yes, it is. It is. It's actually wider across than a Cessna 182.
180.
Than a 182.
Is like almost about this size.
It's about 2 inches wider across. All right. So so over this side here is where we work on the wing, and then I'll show you the fuel tank that we were talking about. So we'll start on this side first. This is what the finished product looks like. So this is actually the bottom of the wing. So this is the part that will be lifted up and put on top of the fuselage itself. And then this is where the fuel tanks go. One there and one there. So the fuselage itself will actually be attached right here. Right here. And then these are access panels to get to the ADAHARs, which is the part that interprets the GPS information. So all of that is accessed through here. And then these are access panels from the outside. So the fuselage, if you think of it, again, goes right here.
And then the fuel tank goes here.
Correct.
I see.
Very simple structure.
Very simple. It is very simple. But it is very effective. You know, so like when I'm getting ready to teach people or demonstrate to people about stalling the airplane, I have to tell them don't laugh, because when this airplane
It tries to fly.
you feel, I mean, it does a little bump and you hear it in your ear, and then the nose just comes down. That's it, done. Wedges are on here primarily so that as you're putting, that's the aileron. So as you're turning, the aileron goes further and further into the slipstream, which makes these wedges go further and further out into the slipstream, and it's pushing back. And that's just to give the pilot some tactile, so you feel it in your hand, so you're not overcorrecting. So as you put in more and more aileron, you're getting more and more pressure back in the stick, so that you're not doing this.
But that's actually the aerodynamics pressure. It's not like a mechanical
There's no mechanical, it's just aerodynamic pressure.
Wow.
So these are the rods. So this is on the, let me see here, let me kind of get a...
Left,
That's
right.
left, right. Okay, thank you. All right, that
So this
way.
is the bottom.
Yes, this is the bottom. Yep. Yes, exactly. So again, here's the middle, fuel tanks are right there and that kind of thing. So then they are connected, so they come up through posts and are connected here to then give your movement to the ailerons out there.
Complete rods.
So these are the fuel tanks.
Fuel tank?
あ、
Yeah.
フュエルタンク。前衛にあるで。
So yeah, so this is the finished one, and this is the top. That's where the fuel would go in right there with the fuel lid. Right, so this is how it would go in with the fuel sump right over here, right there, exactly. So it goes into the wing just like that.
And it's kind of reversible on the right or left.
Correct. I had forgotten about that. Thank you, Wes. But yes, you can actually, you know, go in either side.
Beautiful.
And then this again we make here.
It is very surprising to me to locate the fuel tank in leading edge. So, how will the affect to CG? I mean, if the
So with this airplane, it has a very strong forward CG. I mean,
Forward CG.
because that's one of the things when you land is you have to keep the stick back, or the nose is just gonna come down.
okay.
And a lot of that is and even when we're flying, the airplane is rigged to kind of keep the nose up a little bit while you're flying,
Okay.
because the CG is a bit more forward.
More forward. Okay.
Correct.
So,
And even as you're flying with the reduction in fuel, I honestly don't really feel the difference. I really don't. I mean, sometimes I think about it as a pilot, obviously, but when I'm landing, you know, I've landed with almost empty tanks and I've landed with fuller tanks, and it really doesn't feel a whole lot different. No, a lot of that has to do with the elevator.
okay.
Yeah.
But there was a conscious decision of having the tank in front of the wing, right? Not really in the middle or anything.
Correct.
Was there any particular reason why?
So
you
the
wanted to
main
do that?
thing was maintainability.
Maintainability.
Yeah, correct, exactly. I mean, everything about the airplane was that it could be maintained, fixed, repaired, replaced in the field.
True.
Whereas, you know, if it's in the wing, then you have to take
have to
pieces
open
of the
up
wing
and all the-
off to get to it. Whereas this, it's, you know, just take the screws out, pull it out, done. From a pilot perspective, you appreciate that, and definitely from an owner perspective. So, for instance, for annuals, so the annual inspection, you know, it's a lot of our owners are saying that they've gone from whatever they had, whether it was a 152 or a 172 or something like that, they were having like 18 to 20 hours of labor for their annual inspections. We're actually seeing about 8 hours.
8
1 hours, because the mechanics don't have to take pieces of airplane off. They can actually just access everything that they need to
Okay.
access.
So it helps the maintenance cost.
It
as
does.
well.
It makes it go a lot faster, so their annual inspection costs come down, because as well as it's a newer airplane, so they don't have to buy as many parts. let me take you over and show you one of the more finished one here. So this is one of the more finished ones, meaning that the engine is on, the propeller is on, the wiring is done, the panel is in, that kind of thing. It still has more work to be done to it before it heads through the door, but this is the more finished product because, as I said, the engine is actually hung on it. And this is the Continental 0200.
100 horsepower.
100 horsepower, exactly right.
So because you're kind of looking at the customer in the market who's flying in field, is there any particular thing that you're kind of paying special attention because of the dust or anything?
So for the, not really. I mean, because it is designed to fly off of gravel and grass and that kind of thing, the main consideration that we did to that is the big tires.
Yeah.
These are the same tires. So if you think about the bush planes of the Flying Alaska, like the Cessna 206 or the 182 or something like that, those are the same tires that they use. Another concession that we made to flying off of grass or gravel and that kind of thing is a rigid nose gear.
Nose gear, right.
So it's not a compressible strut that you would find on a Cessna or a Piper or something like that. And that's to maintain the distance of the prop off the ground. So that even if you do come in and the nose falls, it's not going to the strut. There's no strut to compress, so it's still going to maintain that distance.
Okay.
Exactly.
So this is a very strong part.
It is, and that's why it's bolted directly onto the fuselage.
Yeah. So in that case, on the asphalt or paved, you have a little bit shock coming up from the nose gear when you landed and settle down? Because you're...
So the way that I teach it to land is to really make sure that you come down on the main gear first, because that is the composite material. So this is the composite material main gear. So this will actually flex, and when we tested the one back there, it actually, and we dropped it, it actually flexed all the way out so that the belly came down to right here, and then it just pops back up again. It's a spring.
Interesting.
Exactly. So it just kind of, went out, flexed, and then pushed the airplane right back up again. So when landing the airplane, what I teach is that you have to use ground effect to land the airplane, and it's to come in as slowly as you can and make sure that you come down on the main gear, so that the initial shock of the landing, even if you're coming in and just putting it down on the ground as opposed to putting it down on the ground, but the main shock, the initial landing shock, is all going to be born right here. So then if the nose gear does come down, and it does come down hard, it's not as hard as it could have been.
Okay. So this is a composite.
That is composite material. It's just wrapped right now.
Wow.
And you might be able
So
to see the... Yes, there, I was just about to say. So that's where it comes up.
Oh,
And that's the attachment point right there.
Yeah.はい、というわけで、バッションエアクラフト工場見学めちゃめちゃ楽しかったです。やっぱり GA ジェネラルアビエーションって言われるその自家用で空を飛ぶっていう世界がやっぱり広いアメリカだけに、まあめちゃめちゃいろいろ楽しいことがありましたね。今回はお友達、飛行機友達のキッシーさんに誘っていただいて本当にありがとうございました。これからたまにキッシーさんと地元シアトルすごい航空産業が盛んなので、地元のこういう工場とかの見学をさせてもらう動画シリーズにしよっかねなんてさっき話してたんですが、まあおおむね見ていてわかると思うんですけど、やっぱり自作飛行機に近いような状態でどんどん作っていくんですけど、それでもお客さんのことをすごい真剣に考えていて、あと一つ私が興味深いなと、二つですね思ったのは、隣に同じオーナーさんのダイノンのアビオニクスって、要はフライトのコンピューター系のものを作っている会社が隣にあるんですけど、 その会社とのその融合っていう部分がすごくしっかりしていて、きちんとしたマーケットを目指してるなと。で、録画には入ってないんですけど、このまま、電気モーターの飛行機とか、そういうところを目指していくんだと。で、誰でも簡単に軽く飛べる飛行機をしっかり作っていくっていうコンセプトをお話しされてましたし、今アメリカでもすごくバックオーダーが入ってあちこちで売れているんで、特にそのアメリカ中部の方で同じ空港に4機とかバッションがあるところがある、バッションのオーナーさんが4人もいるところがあるらしいんですけど、そういう風にどんどん広がってるんだなというところが一つ驚いたところと、もう一つは皆さん多分動画の中でも分かったと思うんですけど、燃料タンクがきちんと取り外しできるようになってる、修理のためにとか交換のために。あれもやっぱりアメリカで私もものづくりしてますけど、コンポーネンタイゼーションっていうコンセプトですね。物事をコンポーネントに分けて何かがうまくいかなかった時に取り替えられるようにするとか、そういうコンセプトがしっかり入ってるなというところに非常に感銘を受けた、工場見学の一日でした。皆さんも少しは楽しんでいただけたでしょうか。
Thank you for visiting Vashon Aircraft. And next time you see me, we'll be flying.